Okay, let's do some examples with vertical shift up or down. So as always, I'm going to graph everything except for that vertical shift. This guy right here, he's going to have a period of pi over b. B is 1/3. Right, there's b. So pi divided by 1/3, which is pi times 3/1, or 3 pi. Okay, there's our period. Our asymptotes. This is cotangent, and I just always remember that cotangent starts at the y-axis, which means its first asymptote is always at x equals 0, right? On the x equals 0 line. So there's one at x equals 0, and then you count out 1, 2, 3, and 4 lines. And just like before, the period goes on that fourth line. So my period was 3 pi. All right, so my asymptotes are at 0 and 3 pi. Intercept is going to happen exactly halfway in between there. So our intercept, uh-oh, I can't count by 3 pi's though, right? Sure I can. This guy right here is going to be p over 4, which is 3 pi over 4. Okay, 3 pi over 4. This one's going to be 6 pi over 4. You're doubling how many there are. Sorry, adding 3 more of them over there. So this was 1 3 pi over 4. This guy right here. 1 3 pi over 4. This guy is 2 3 pi over 4. This guy is 3 pi over 4. And of course, this guy is 4 pi over 4. So right here, this 2 and that 4 will cross out, and this is actually 3 pi over 2. This one is 3/1, 3 pi over 4, so it's going to be 9 pi over 4. It doesn't have to be something simple like we've been doing. It can be something that works just like that. Okay, intercept. Intercept happens exactly halfway in between your asymptotes. So it's going to go there. It's going to happen at 3 pi over 2. Then it wants to know special points. Now, special points again have to do with that asymptote, or sorry, amplitude. So our A, our amplitude, is that number out in front. So that's 2, which means your special points are going to be, whoops, forgot to put labels over there, didn't I? 1, 2, 1, 2, negatives. Okay, this is cotangent, which goes downhill. He's a downhill slide, right? So I've got my intercept, I've got my asymptote. Halfway in between my asymptote, halfway in between my intercept and asymptote is a special point. It's cotangent, so it goes up on the left, and then over here, it's going to go down on the right. So then I would connect those dots, right? I would say, oh, it goes up, goes all the way down the asymptote, curves a little bit, and goes up there. Not beautiful, but close enough. At least it's curvy, right? Okay, so that is 2 cotangent of 1/3 x. That's the orange thing that's right there. We do have one more thing to add to it, though. We've got to make that shift moving down 1. And it is just as easy as before. This point, move it down 1. This point, move it down 1. This point, move it down 1. The asymptotes do not change. So now all you got to do is take your, I got to take that orange line out of there. Come on, 9. Silly, I don't remember what was written down there. Okay, so we are going to do our down 1. That means here's this orange point, goes down 1. Red point, down 1. This orange point, down 1. Then you draw your regular graph. Comes up the asymptote. draw. Up the asymptote, goes through my purple points and back up the other side. And that is a beautiful cotangent graph. Asymptote, asymptote, intercept. Special points using the quote-unquote amplitude, and then that becomes your graph. You just connect the curves. Let's do a tangent one. Okay, this one has a couple of things going on. It's got a reflection. This one's got a shift down, right? It's been moved down 2. And then this, of course, is going to be our quote-unquote amplitude. Oh, it's so fussy. Okay, let's start. Let's go with, first of all, period. Period is pi divided by b, which in this case is 1. Good. So we got a nice, easy period of pi. Then we're going to need our asymptotes. Now remember, for tangent, the asymptotes are at the period divided by 2, the positive and negative versions of it. So these are going to happen at positive and negative pi over 2, which is 2 spots away from the center. I guess you can think of it as to count, your count by p over 4. So this is pi over 4. This is 2 pi over 4, or pi halves. And then the other direction is negative pi over 4, negative pi over 2. It'll always be 2 to the left and 2 to the right, but if that helps you label the whole thing, you can. So asymptotes. I like the line picker. It's kind of nice. Oh, wait, they'll do it dashed for me. So asymptotes right here, 2 to the left of 0 and 2 to the right. Okay, easy. Let's see, intercepts. The intercept happens halfway in between, always. So your intercept's going to be at 0, 0 for now. It might move. Then your special points. Okay, special points happen at the in-between spots and the amplitude. So over here at this special spot for tangent, I didn't even label that axis. Shame on me. 1, 2, 3. 1, 2, 3. Okay. So for our special points, you go to this special point, or sorry, this next marking on the line, negative pi over 4. For tangent, you would go down 1, 2, 3 and put your special point. And then on the other side, it would be up 1, 2, 3 and put your special point, and then do your asymptotes and draw your graph and all that stuff. But it's been reflected. So let's put this reflection in right now. This intercept does not change. This special point's going to move to the opposite side and become at positive 3, whereas this point right here will move down and go to negative 3. Now, when you sketch that graph, it's going to look like cotangent. It's similar to a cotangent graph, but notice how it doesn't have an asymptote at 0. It's got an asymptote at negative pi halves. So it's similar graph, but it's shifted a little bit. Okay, final step. I'm going to take that purple one back out now while I'm thinking about it. Final step now is that we've got to do this shift down. It says shift down 2. Okay, take my point here. I'm going to go down 2. There's his new spot. Down 2. There's his. Down 2. There's his. I need to add some labels here. Negative 4, negative 5. And then we're just going to connect our dots. So Asymptote curves, goes through those lines, curves. That's beautiful. So as always, these shifts always get done last. You can do reflections right before you do those. That is a horrible graph. I can't even handle it myself. Boop. There we go. Curved at the last minute. They're hard to draw.